All right, here we are for our last example of graphing polynomials. So we have the function k of x equals negative x to the fifth plus x times x plus 8 times x cubed minus 16x. You know, sometimes get jumbled on words. That's why I have it written down. So again, same with our last three examples. I strongly encourage you to pause the video, try to work through it on your own. When you get stuck, just watch the video up to that point, correct yourself, pause again, and keep going. That way you are really actively developing that independent ability to work through questions without necessarily watching someone show you step by step. That is how we go from novice learners to masters. So our first step is our end behavior. So we have our leading term. It's negative, which means the right side is going to go down, and it's an odd degree, which means the left side is going to do the opposite thing. So over here, right side goes down, left side goes up. That is our end behavior. Second step is finding our y-intercept. Is there a y-intercept? It's a good question. We don't have a constant term. So it turns out there is a y-intercept. Because what happens when you plug in 0? K of 0 is just equal to 0. So if there's not a constant term, our y-intercept tends to be 0. I can't think of any case where that would not be true if there's no constant term. But mathematicians don't like to just say things generally without proving it, and I don't feel like proving that right now. So probably if there's no constant term, the x-intercept is 0. Excuse me, the y-intercept is 0. But yeah, carrying on. Step 3 is to factor, find our zeros, their multiplicity, and describe how the graph behaves at each x-intercept. This isn't in quadratic form. Grouping's not going to work. The next best thing to look for is a GCF. When we're looking for a GCF, if we can pull out any negative signs, that's really helpful as well. So I'm going to factor out negative x. So I get x to the fourth minus 8x squared plus 16. And notice, here it is again in quadratic form. This is a really handy formula, and I just happen to like it. So a lot of my examples have it. So 16, negative 8, well, it's negative 4, and negative 4, multiply with positive 16, add up to negative 8. But you've paused the video and already worked through it, so you knew that. So we have negative x times x squared minus 4 times x squared minus 4. These are differences of squares, so we get negative x times x minus 2 times x plus 2 times x minus 2 times x plus 2. I am certain someone out there on the internet will take that clip of me saying x minus 2, x plus 2, just putting it on repeat as some sort of electronic beat. I don't know. If it happens, share it with me. And then we can simplify negative x times x minus 2 squared times x plus 2 squared. And now I'm going to get rid of some of the intermediate work because I want to be able to list my zeros and their multiplicities. So we have zeros. Well, we get 0 from negative x, positive 2, and negative 2. This time the factors did not get written in numerical order, but I do want to write the zeros in numerical order. And then the multiplicities. Well, it's 1. The 1 goes with the 0. And then our two negative 2 and positive 2s, negative 2 and positive 2, have 2 as their multiplicity. So the graph is going to touch, cross, touch. Now step 4 is to plot and label. Step 5 is to draw the graph. So I need to go to negative 2. And this is going to be a touch. And then 0 is going to be a cross. That's also my y-intercept. and then positive 2 is going to be another touch. And then I start up on the left and down on the right. That was the end behavior we discerned from our leading term test. So we're going to go up, then touch, cross, touch. And this is why it's really helpful to put our table in numerical order. So at the end, I can match. Okay, -2, touch, 0, cross, +2, touch. And it's just another way we can check our work to make sure we haven't made any unintentional mistakes, whether it's just like I did before, where I always almost put the 1 with the 2 instead of the negative. Anyways, it helps us check our work just to be sure that when we turn it in, we have actually demonstrated what we know, rather than being held back by a careless mistake that we could have prevented had we been paying a little bit more attention. And it's actually pretty common that as you become more skilled, you stop paying attention to the things that feel less important. And so sometimes the little details that we stop paying attention to are the things that turn into careless mistakes. I have definitely failed plenty of math tests and quizzes in my life because I thought I knew it and I made careless mistakes. I didn't check my work and then it came back completely wrong. So if you have something built in to how you're organizing your information that helps you quickly check at the end that you've done everything correctly, it's just one more way to make sure that we're guarding ourselves against those careless mistakes. And with that, this wraps up our unit on polynomial functions. Hopefully you feel that you are now a master of polynomials. They are incredibly powerful functions. They can model everything from motion to finance and many things in between. And if you can really learn how to manipulate polynomials, you are well on your way to doing many amazing things with math.